Good afternoon, everybody. My name is Steve Link, and I've been with CDM Smith for over 28 years. I've been working on alternative delivery projects for CDM Smith for 25 of those 28 years. My first design build project was an $8 million water plant expansion 25 years ago. And since then, I've served as a senior PM on many large water plants, CMAR, progressive design build, and design projects, and most recently served as design manager for our $1.8 billion progressive design build Houston Northeast expansion project. And that's what I'm going to be talking about today. My session will give you some project background, and then also discuss various design elements and construction elements, and then finish up with the challenges that we faced on the project and cover lessons learned and best practices that we've gleaned as we move forward. So Houston Waterworks team, that was a joint venture. HWT, as we refer to it, was created as a 50-50 joint venture between CDM Smith and Jacobs, where we shared management responsibilities, and we took the best talents from both firms. We also formed an HWT SCADA team, where we're currently self-performing all the fabrication of all INC panels, and we're performing all the SCADA work on the project. Let me give you some project background. Pictured off to the right here is an old groundwater well in the Houston area, where you can see that the pump and pump pad is lifted up from the ground about 6 to 7 feet. Well, that's not what happened here. What happened was that the ground actually subsided 6 to 7 feet. So there were regulatory mandates from Harrison, Galveston, and Fort Bend subsidence districts that require that 60% of all water demand be supplied by surface water sources no later than January of 25. This chart illustrates the gradual implementation of the regulatory mandates as a percentage of water demand by surface water. And you can see the current requirement of 30%. And our project is intended to meet the 2025 mandate of 60%. In addition, there are further mandates that would require in 2035 that 80% of all water demand would be supplied by surface water. So I'd like to give you a quick overview of the City of Houston's water supply system. The City of Houston supplies water to 4.6 million customers over a 4-county area comprising of just under 1,600 square miles. The project is being funded by the City of Houston in 4 regional water authorities. City of Houston is funding 16% of the project. North Harris County is funding a little bit over 35%. West Harris County is funding 26%. North Fort Bend County about 21%, and Central Harris County about 1.5%. So let me give you a big picture plan of what's happening here, how we're getting water to meet this demand. So here we have the big picture. This is a global map of the Houston area. My cursor is showing the Trinity River, and there was the Loose Bayou raw water intake pump station that is pumping 300 MGD of water that can be expandable to 500 MGD in a pipeline about a third of the way, and then about 2/3 of the way in an open channel canal that flows into Lake Houston. Okay, the city and North and Central Harris County also have 2 transmission main projects going on. There's the transmission main shown over here, and then the West Harris Regional and North Fort Bend County has another transmission main. Both of these transmission mains are forecasted to be completed in 2021. Our project is the new plant expansion and the intake that would be completed in 2025. I'd like to give you a quick timeline on this project. HWT was selected in the first quarter of 2016, where we started design. And you can see here, we started construction as early as the first quarter of 2017. By the time we issued the 100% design documents, in June of 2019, we had over $250 million of construction already underway. Phase one of our contract requires us to have 80 MGD of new surface water treatment plant ready to go by the fourth quarter of 2022. And phase two would be complete, where we would have 320 MGD of surface water treatment plant in the second quarter of 2025. So the progressive design build model was chosen. That was the selected model for this project. The design build process is an alternative form of project delivery that I'm sure you're very familiar with, where it combines engineering construction into one team and minimizes the finger pointing that can take place between the engineer and the builder. And the construction would start when the design reaches an appropriate level of definition. You can have early work packages and stuff. Well, we chose, the city of Houston chose the progressive design build model. And the differences here is you have an increased owner input, where the client would actively participate in the design definition to at least the 60% definition level when you achieve your GMP. And it allows for an off-ramp in the event that you're not able to negotiate that GMP with your design builder. And it provides enhanced, there's more transparency into the design builder's cost when you see the design builder proposed maximum price for the project before it's tendered and contracted. You actually have visibility into the overall cost and what makes that up. As we move from the GMP into the final design process, the client has less input into that process, but we all keep the GMP well in sight. And it's just a very collaborative single point of responsibility methodology that's worked very well for the city of Houston and the authorities. So I'd like to cover some design elements. We already covered this to some extent, in that how did we accomplish the overall design effort is we had we co-located our integrated design builder team with the owner and the owner's advisor and the subcontractors, where we were all under one roof. And before we had construction ongoing, we were in a separate collaboration center that was away from the construction site. But once we had construction going, which happened the first quarter of 2017, we moved on site. And at the point of moving on site, we had what we call Trailer City, where we had representatives of all parties present. And we had ready access to the owners, the engineers, and the constructors. And it really helped form a sense of teamwork, where we had team building events, and it built trust, which is vitally important in any alternative delivery project. I'd like to cover with you some of the design methods and tools. Aside from co-locating with the client, we conducted over 250 collaborative workshops and meetings with the client to establish what it is that we were needing to design to meet the client's needs. We leveraged the Bentley MicroStation BIM tool. In fact, our project was one of 3 finalists in the water and wastewater treatment plant category of a big world conference that happened in Singapore in 2019. Using the Bentley tool allowed us to do clash detection. We had over 72 different facilities in this project, and it greatly enhanced cross-discipline coordination and greatly assisted in cost estimating the project as we advanced the design from 30 to 60 and so forth. So this slide shows, highlighted in yellow, existing facility. There was an existing 80 MGD treatment plant facility, and there was an existing raw water intake structure shown in yellow. Highlighted in red is our 320 expansion footprint. And then we also had a new intake pump station that hung out into the Lake Houston Lake about 1,000 feet. And we had 2 brand new twin 108 diameter pipelines, and each pipeline was about 1.4 miles each. So my next slide actually shows our federated model, where you can look at the overall, all 72 facilities with the site civil, site electric and site yard piping. We're flying into the treatment structure where we can see the north pre-treatment chemical feed systems. We can see the flocculation basins and the sedimentation basins. The flock basins and set basin, each one was designed at 42 mgd. We had lamella plates, and we used chain and flight sludge collection equipment. As we pan back into the flocculation basins, you can see we have 3-stage flocculation. Each stage had a total of 5 mixers, total of 15 per flock basin. The settled water from this treatment structure would flow then to the ozone contact basins. The ozone contact basins, there were a total of 4. Each basin was rated at 84 mgd. There were 6 2,900 pound per day ozone generators. And this was the place where we accomplished our primary disinfection using ozone. We also each contactor had 2 thermocatalytic ozone destruct units, and the ozonated water from this structure would then flow to the filter complex. Here we're going to pan back out of this model, and we'll see the 2 of the 8 100-foot gravity thickeners. And then in the background here is one of 2 filter modules. Each filter module had 12 filters. Each filter had 2,300 square feet. Happens to be the 2nd largest filter in the US. Each filter has 26.5 mgd of filter capacity, which is very large. As we pan through the filter pipe gallery, we can see the various piping arrangements, and we can see the filter effluent piping that is collected and then transferred over to the transfer pump station. The transfer pump station takes the filter effluent water, then provides upstream of these 6 pumping units is a mix well. And in the mix well, we add sodium hypochlorite and liquid ammonium sulfate so we can chloraminate the water. We also add fluoride and other chemicals that we need for water quality purposes. But this mix well is designed to be upstream of the transfer pump station. Each pump in the transfer pump station is sized for 45 mgd. And then you can see here a series of in the mix well, you can see a series of mixers that was designed using computational fluid dynamics modeling for enhanced modeling and mixing. And the filter effluent piping from the filters is conveyed here to the transfer pump station, which goes to the clear wells. Here shown, switching over to the solids train, is a 3-story dewatering facility where we have some of the largest centrifuges manufactured. Each centrifuge is 75,000 pounds. It's 44 inches in diameter. On the 3rd floor, we have the centrifuge, both combination that can either serve as a dewatering or a thickening centrifuge. We have that capability. On the 2nd floor, we have the centrifuge output conveyors and the truck loading conveyors. And on the 1st floor, we have our truck bays, our 6 truck bays where we haul off sludge. So now I'd like to cover some construction elements. As I mentioned to you, our project involved early work packages. The first early work package that we had was awarded to Laser Construction. It was primarily related to site prep, where we cleared and grubbed over 90 acres. And we started shaping up the stormwater and the roads and just basically a logistic package. Early work package number 2 was basically a foundation package for the filter complex, the phase 1 filter complex and transfer pump station. This was awarded to McCarthy Building Companies. And again, it was primarily for the treatment structures, the west filter complex and the transfer pump station, just the underslab piping and dewatering facilities. Early work package number 4 was the raw water pipeline. This was awarded to Bernard Construction, where we installed our twin 108-inch pipelines, and we tunneled underneath Westlake Houston Parkway. We also constructed the electrical duct bank and some chemical piping out to the intake pump station. And finally, EWP6 was where we constructed the foundation package for the intake pump station, which was awarded to McCarthy, and the flock set basin for phase 1, which is awarded to Balfour Beatty. We also purchased major equipment, and we began the yard piping phase of the project. So we've got 4 main contract packages. The first package is the North Plant, where we have a contract value of about $282 million. This was awarded to Balfour Beatty. And again, major facilities constructed here were the pretreatment chemical facilities, the rapid mix basins, the flocculation and sedimentation basins, the ozone facilities, and the gravity thickeners. The second contract package was referred to as the Central Plant, which also included Early Work Package 2. The value on this contract was about $245 million. This was awarded to McCarthy, and it included both the filter modules for phase 1 and the transfer pump station for phase 1 under Early Work Package 2, and then the entirety of the Central Plant for the main project of the Central Plant. And then the third contract package was the South Plant. South Plant was contracted value of about $142 million, and it was awarded to 3 separate subcontractors. Alberici was the primary, the contractor in charge for the dewatering building that we just saw. The 4 12 million gallon ground storage tanks are being constructed by Preload, and then PLW Waterworks is constructing the 2 high service pump stations. And then the fourth package here is a $16.6 million package that was awarded to Horizon Group International, and that's for the administration building and the maintenance building. So there was another $406 million that was awarded. Some highlights here: the intake pump station for about $70 million to McCarthy. We mentioned the yard piping for PLW Waterworks for about $141. We had Site Electric that was awarded to Fisk. Substation, electrical substation, was Dashel. HWT SCADA was doing the INC, and the liquid and residual EQ basins was Industrial Texas. And then we had various vendors that we provided some early out equipment. HWT procured for about $4 million. So this, I thought it'd be fun to look at the project where we are today. This drone was actually taken about 2 weeks ago. We're flying over the where future phase 2 ground storage tanks are going to go. Here's the phase 2 high service pump station. Off to the right here at my cursor, you can see the liquid residual EQ basin. Here's your substation for the plant. And then you have the phase 1 high service pump station over here, and then you have the filter complex number 1 for the 12 filters over here to the right, and then you have the 2 12 million gallon ground storage tanks for phase 1. And then we move up to the Alberici package, which was the sludge EQ basins and the dewatering building. And we're gonna, in the background here is the existing 80 MGD plant. And then we're gonna pan back out. You can see the administration building and the maintenance facility, as well as the phase 1 north plant, which is the flux sed and the pretreatment chemicals. And you can see 2 of the 8 gravity thickeners that's being constructed. This is an ozone contact basin, facility 252. And then we pan back, we can go past the large sedimentation pond, and then we'll hit phase 2, basically a duplicate of phase 1. And then we'll see future phase 2 flux sed, and then you've got your gravity thickeners here for phase 2, and then here's your phase 2 filter, which will be another 12 filter modules. And then we're going to pan out. We've got some stormwater detention, and then we've got our 1.5 mile flyover of our raw water pipelines. There's 2 108-inch pipelines in an existing corridor with a 60-inch raw water pipeline. We also constructed within this corridor. We constructed a new electrical duct bank to the intake pump station. We've also got chlorine dioxide that feeds the intake for zebra mussel control. We're about to fly over Waterworks Parkway, where we had to tunnel 2 pipelines beneath the road. That was, as all tunnels are, that was very interesting. And we're getting closer and closer to Lake Houston. We're starting to see the intake pump station in the background. As we come out of the clearing, you can see all kinds of, in the raw water pipe gallery, the raw water corridor, you can see all these housing. We had to be a good neighbor as we were constructing all these facilities. We're coming up now to the existing intake, or the existing raw water pump station. And then you can see the new raw water pump station. I also mentioned to you earlier that we constructed a new electrical building that would service the intake pump station. This intake pump station, it's basically the bridgeway out 1,000 feet into Lake Houston, where we house 6 65 MGD pumps. We've got the 208-inch pipelines that fly, or that run on top of the bridge. And this is just a different vantage point of the intake pump station, where you have all your pumping units in here, and then you have your electrical facilities and your HVAC mechanical rooms on the backside. So this drone flyover was taken just 2 weeks ago. Pretty neat. Okay, I'm going to move into virtual design in construction, VDC. This is something we're using on this project. It's extremely beneficial and helpful on this project for many reasons, but most importantly, it's a federated model by using we're incorporating it into Navisworks. We incorporate all 72 facilities, including yard piping, site electric, site civil, to reduce any conflicts, reduce any field conflicts that could come up during construction. It really provides, as a design builder, less rework, minimizes RFIs. It really does also improve interdisciplinary coordination and collaboration, both during design and in construction. We're trying to sequence trades in and out. Overall, it does reduce the field conflicts that otherwise could make itself present, manifested in construction. Here's just a quick couple of snapshots of the intake pump station, the McCarthy package, where you have a 3D rendering, and then you have sort of time-lapse photography. These are when the initial piles were constructed for the intake pump station. And then this photo here it's probably about a month old, where you can see here, again, the intake pump station, there's 6 65 MGD raw water pumps. We got space for 10. Our project will have a firm raw water pump station capacity of 336 that would be expandable to 588 MGD firm in the future. So the raw water transmission main, lots of involvement with neighbors, all kinds of dewatering challenges that we experienced. You can see here the twin 108s that were installed, and it's hard to really grasp the size of how large these pipes were until you can see photos of men working beside them. But nonetheless, here's remember I mentioned to you we had a tunnel under Westlake Houston Parkway. That was a challenge. We had to hand tunnel that work. Moving through to other project components were the pre-treatment modules. Remember, I indicated that there were 8 flock and set basins. Each basin, each flock basin and set basins was 42 MGD. The rapid mix train, there were 4 of those, and each rapid mix train was 84 MGD. Again, you can see, we had incline plate sedimentation basins with chain and flight sludge collection equipment that you can see here in the model. This happens to be a photo of the 3D rendering of our BIM model. Over here to the left and on the right is a photo that was taken just a couple of weeks ago. This is phase 1, filter module number 1. Again, it's got 2,300 square foot granular media, and these are biological filters, okay? Second largest filters in the US. Very, very impressive. Each complex is as big as a football field. Moving to the transfer pump station, rendering here, in this case, is over to the right. Remember, we had a total of 6 45 MGD pumps that pumps to 4 12 million gallon ground storage tanks. This is phase 1 transfer pump station, currently being constructed by McCarthy. I'm going to move in now to some of my some challenges and lessons learned and best practices that we experienced on the project. You may remember, I remember very well, Hurricane Harvey, August of 2017. It resulted in flows to Lake Houston in the order of 250 billion gallons per day. Okay, that's 33 trillion gallons of water that fell during Hurricane Harvey. And the interesting thing is, we saw on an earlier slide the footprint of Lake Houston. There was enough water in Hurricane Harvey to fill the entire complete water to the Lake Houston it was enough inflow to provide for 13 complete water changes in the lake, the entire lake, in a 24-hour period. So I don't know if that gravitates or that magnitude is properly conveyed. Here's some photos of the flooding. My next photo here happens to show Lake Conroe spillway during normal flow, and this is what we experienced the spillway after Hurricane Harvey. I will say that the takeaway from this is that after the hurricane, we raised the finished floor of all the critical structures 2 feet above the 500-year floodplain to remove those from areas of outside of the 500-year floodplain, which proved very, very helpful. The other takeaway that we experienced was in the solids realm. From Hurricane Harvey, we started the design in the order of designing the dewatering equipment on the order of about 236,000 pounds per day. Once we finished, we increased it by almost 300%. And we're on the order of 700,000 pounds per day that we ended up designing for. So big takeaway. The other project challenge we had was Tropical Storm Imelda in September of 2019. Now, keep in mind, this is just a tropical storm, but it happened to be the 5th wettest tropical storm in the US in history books. It put in East Houston, which is where our project is, it put over 40 inches of rain and really brought back memories of Harvey. And it was really beneficial to have all of our critical structures being built up 2 feet from the 500-year floodplain. Other project challenges just recently, February of 21, was Winter Storm Uri. To effectively treat the challenging water quality conditions, we have to be flexible and resilient to protect critical infrastructure in communications, storm events and flood protection, as well as heat protection, freeze protection, power redundancy, and just the transportation of facilities for staff, chemicals, and equipment. So as a result of Winter Storm Uri, we're fortifying the project to address with some of these extreme weather conditions. So given the treatment challenges and the significant cost of the plant expansion, it was critical to maximize the return of investment. And our goal was to ensure each process could provide multiple treatment benefits. HWT worked with the owner's advisor, Carollo, to pilot the treatment scheme here. And for example, chlorine dioxide, I mentioned to you, it's for zebra mussel control. But it helps out with manganese oxidation and bromate minimization because ozone is fed downstream. Ozone is used for, as I mentioned, primary disinfection and taste and odor control to enhance the biological filtration. performance. So the biological filtration also enhances the reduction of organics and taste and odor compounds, as well as emerging contaminants. So that was what I would refer to as a best practice. So this is just some project notables here. This project, largest progressive design build project delivered in the world for a water plant. Okay, it supplies drinking water for over 2 million people. We've got a 320 MGD facility that can easily be expanded to 426. We have over 50,000 linear feet of piping infrastructure over 60 inches. We've got the largest, we've got we've got four 44-inch diameter dewatering thickening centrifuges. Those are the largest installation of centrifuge technology in the world. Very large vertical turbine pumping units, anywhere from 400 horsepower, 75 MGD to 115 PSI in size. And then I mentioned second largest filters in the US, 2,300 square foot per filter, 26.5 MGD. We've estimated over 6 million construction man hours. We just achieved a major safety milestone of 4 million man hours without a lost time accident. Great accomplishment here. We had estimate over 1,400 workers on site at peak production. Currently today, we're at 1,350. And every day we do COVID monitoring. We have an app. We've got 1,350 people that where we, in teams, we take temperature checks to make sure that people are safe. We have over 200,000 cubic yards of structural concrete. That's interesting because you can compare it to the World Trade Center, where there's only 1,500,000 cubic yards of concrete. We have over 1.5 million cubic yards of earthwork, and we had over almost 6,000 drawings. When you stack all the drawings and specs up, it was over 6 feet tall. So it was definitely a project to remember. And I guess with this, I'd like to turn it over for any questions that you may have. We've got a little bit more than 10 minutes to answer any questions that you may have. Maybe I can ask a question to the viewing audience. Did my videos come through okay? Was there any time lapse that took place? Were you able to see that fairly easily? Question just came in. Question number one, can you highlight the key success factors for this APD model, for such a large project? Yeah, I will. I'll try to do that. I think the most important aspect, critical success factor, is developing a trust with the client and the owner's agent. We work very hard working with and collaborating with the owner to establish what we would call the standards of care for the various unit processes. And it was as I said, we had over 250 workshops, and within each workshop, we covered a lot of ground. And every workshop, we had meeting minutes and prior to those workshops, we would provide the meeting content, both the agendas and the handouts that would be needed prior to the workshop. So the client and the owner's agent were able to assimilate that information and kind of hit the ground running when we would get in there. We were very successful in that regard. And then after the meeting or workshop, we would publish meeting summaries, and then the client would have an opportunity to comment on those to make sure that we captured it correctly. But establishing guiding principles for the project and all those workshops was absolutely critical to establish the trust that is so much needed in a project such as this. Hello, Hala. Is that your question, Hala? Okay, question number 2. With so many different contractors working in the same footprint, did you have any challenges with coordination of deliverables? I would say unequivocally yes. We are, you saw that the original 80 MGD is using about a fourth of the footprint. And then we have 90 acres that we're putting basically 426 MGD worth of infrastructure. So we're very compact, and absolutely we've had lots of challenges to make sure that we have different trades coming and going with not just the trades, but the trades within the various construction packages. And then where the call it the lines between the contracts, needing to coordinate that work properly. I mentioned the tool that we used most readily was VDC, the federated model, BIM model, where we coordinated the facility 3D models with the site civil, site electric, and site yard piping to make sure that we're not missing something. Because undoubtedly, anytime you're working in a workspace, it's very possible that the work activities can conflict with another one. So using the BIM tool, the federated model of Navisworks, and then just good construction scheduling, we've been able to be very successful. Thank you, Bruce. Looks like we got about 4 more minutes. Any other questions? I got a third question that came in. Any lessons learned? Yeah, I covered this earlier. We had, as part of the challenges that we had, we started design, we had we had Hurricane Harvey in 2017. That's when we were in the infancy stages trying to develop the design to 30%, followed by the fallout. And hey, what are we going to do? The existing Northeast plant barely kept things online. And what we learned from that is 100-year storm events happen more frequently than 100 years. And every critical building, infrastructure building, was raised 2 feet. That may not sound like a lot, but it is, because Houston is flat, really flat. And by raising everything up 2 feet, we were able to keep it out, the critical structures out of the 500-year floodplain, 2 feet above. So huge lesson learned, and it proved very well to when Tropical Storm Imelda came through in September of 2019. Not to say that we didn't experience flooding, but what we did is we didn't have the degree of flooding that would have otherwise taken place was minimized by that decision back in 2017 to do that. The other lesson learned that I could share would be, most recently it's, if we're not experiencing hurricanes or these tropical storm events, Texas, we experienced a storm like I haven't experienced before, where we lost power, and trying to fortify the plant. We're well under construction right now, and the first phase is scheduled to be complete, in 22. And quite honestly, we are needing to, we're fortifying the existing infrastructure to learn from what happened in the winter storm Uri. We're increasing the level of heat protection to various small diameter piping, freeze protection and small diameter piping. Double checking the heat design for the various treatment structures and so forth to make sure we're not going to have some problems. Also, power redundancy was looked at as a result of this storm. So between the floods and the winter storm, the hurricanes and the tropical storms, I felt like we learned a lot, and that had a great impact too on the solids production. When the water we increase the solids capacity by over 300%. Okay, as a result of these winter storms, the flood events that took place, and we used the tool. The other takeaways that we used, we came to our design parameters by using good pilot testing protocols. HWT worked very closely with the owner's advisor, Corollo, on that. Thank you, Hala. Looks like I have about another 30 seconds. Is there any final questions from anybody? I'm looking at the wrong clock. We actually have another minute and a half. I'm sorry. About Suzanne Meckler. Thank you, Hala. I hope that next year we can all be in the same room together. 30 seconds to go. That's a wrap. Thank you, guys.